Okay, my name is Huot. I was the senior marker for question 13 and 16 last year for extension 2 mathematics. So I currently am in Mount St. Joseph Milpera. So what I'd like to do is just to go through with question 13 first. Question 13a is about finding the equation for displacement. This is involving simple harmonic motion. So student normally in this question, there should be underlying a few things. I mean, all of this information relevant, but I think the main thing I'm just going to underline is 2√3 from the central point of motion. Okay, the first solutions here is equations in terms of cost. The student's got to recognize that the center of the motion here in X naught here, and they have to find the amplitude and n as well as initial phase. So student will actually come up with answer of amplitude is 2√3, n equals 6, and center of the motion is √3. In this case here, if the student using equation of cost, they find that initial phase is 0. Some students did it by using the diagram, which is a lot less work. Just recognizing where the center of the motion, the amplitude, and to recognize that there's no initial phase for the cost. The next method that student would use is using sine instead of cos. This one here is very similar to the cos, except that when they substitute and find it, they would end up with the center of the motion is √3, the amplitude is 2√3, n equals 6. Also, the initial phase is pi on 2. So that's actually involving more work if they're using sine, but still doable. And a lot of students actually did quite well. This method here, which is not recommended, but it's an option that a student could do, is actually recognizing that acceleration in terms of x. So they use d dx to half v squared to integrate to get v, and then changing v in terms of dx to t. Then they have to encounter these nasty integrations involving the answers as inverse sine if it's a positive, or inverse cos if it's a negative. But as you can see that this method would not be recommended because it involves a lot of work in the integration part of it. For this 13a, majority of students recognize this question, and they were able to state simple harmonic equations, either in terms of sine or in terms of cos correctly, and found the equation. The problem is a lot of students misunderstood the sentence about the maximum displacements from the central point of motion. So what they end up recognizing is, instead of saying that what the amplitude should be, they mix it up, so they're using the wrong amplitude. So that's something that students need to be careful reading the question. So because they confuse the amplitude with the center of the motion. Advice to the teachers about this part is students should know their reference sheet pretty well. So what's available there, and they should keep an eye on the reference sheet, what they can use or is not there, so that they can commit to memory. They also should know that simple harmonic motion, now the questions is in extension 2. It was in extension 1 in the old syllabus. And also know the difference when they use a sine or cos function, so that it makes it easier for the working out. This is part B, so involved with vectors. So as you can see, it's given 2 vectors here. The question is, find the point of intersection of the 2 lines. Okay, the key thing here is find the point of intersections. So it's quite a straightforward question. So all they need to do is to equate the 2 equations, the components. So they have to solve the simultaneous equations and just finding A and B. And after that, student must find X, Y, and Z, because they asked to find the point of intersection. The other thing to mention here is The student don't have to check it because they just have to find a point. It's not about whether it's intersect or not. So for this particular question, students do not need to do the checking part of it. The majority of students recognize this question and they were able to find the point intersection of the two lines, and there's no problem with that. It's just a small number of students need to remember to find the point intersection, as like I said, once the variables are found. The advice for this particular question is make sure that the students understand and use the vector equations. The other thing too is how to find the point of intersections of two lines and be able to solve the equations simultaneously, successfully, so that they don't make mistakes. See part 1. This is actually a very standard question in inequalities. But I guess some of the students were put off because of the right angle triangles that's drawn there, and then some of them actually make it harder than what it looks. So some students recognize that they start with Pythagoras, so they establish that x equals 2 root AB. Then they have the reason to say that the hypotenuse is actually greater than or equals to the smaller side. So then that reason bring them down to a plus b is actually greater than or equals to 2 root AB, and hence the result. But there's a lot of other methods as well that the student attempt, which is all acceptable. So the first one at the top here, we can see that if they're using root a minus root b all squared is greater than or equals 0, because something squared greater than or equals 0, they achieve the result really quickly. Or they actually can look at a on b plus b on a is greater than or equals to 2, and just substitute a as root a and b as root b. They also achieve very quickly as well, the results. This one here, they just have to substitute between the second last line to the last line by letting a squared be a, b squared be b, get the results too. Other method, they reverse it. So this one here, they started with the results and they're showing that root a minus root b all squared, which is positive, therefore true, hence original is true. Also, they can reverse it by doing the same thing here, so they square rearrange it and show that positive. The last one is they could do this by contradiction. So assuming it's less than, and we end up with a minus b all squared, because that's positive and that end up with less than 0, this is false. Therefore, the assumption is false. So they by contradiction, therefore the statement is true. So this particular part of the question is majority of the students recognize this question. And they'll be able to prove inequalities by just using the properties of the squares of real numbers are non-negative, or just by using the right angle triangles properties. Well, a small problem here is a number of students actually were not careful with the signs in perfect squares. Well, the advice to teacher is make sure that, these types of questions, students actually know how to prove it, not just memorizing it. Depends on if there's no showing, they can use it. If it's showing, then you've got to know how to show. And proving, make sure that they don't skip any step and make sure they give reasons as well. This is the second part of that. So prove that p squared plus 4q squared is greater than or equals to 4pq. So all I have to do is to use part 1, replace a by p squared and b by 4q squared. And as you can see, if they substitute into it, they derive the results. Also, they could actually replace a by p and b by 2q, and they square both sides, rearrange it, and they still end up with the same result. As you can see, there's quite a few different ways of doing this. So option 3, they can just go straight and put in p minus 2q all squared greater than or equals 0, expand, rearrange. So that's quite simple, this method here. The next one is actually reversing it. So Assume it's true, rearrange it, and try to prove positive. If the student doing this way, they've got to make sure that they say that is positive, therefore true, hence the p squared plus 4q squared is greater equals 4pq. As I said, the students used many approaches, but the usual approach was to use a substitution. And these particular questions was really well done. It's just a small number of students use the wrong substitution, and they make it really difficult for themselves. The advice to the teacher is to make sure students understand a variety of methods that can be used to prove inequalities. Okay, those could be just substitution into a known results, or using left-hand side minus right-hand side and proving positive, or contradiction, or by starting with a true positive inequality and build it up from there. So as you can see from the varieties of methods, it just opened up to many different approaches for this particular question. For this particular part is the part 1. It's actually proving that e to the I n theta plus e to the negative I n theta equals 2 cos n theta. So all I need to do is to use the MOV, e to the I n theta, which is cos n theta plus I sine n theta, e to the negative n theta, I n theta. Make sure that in this case here, they simplify down to cos n theta minus I sine n theta. And adding the two equations, therefore, they prove the result. So this is a majority of students were able to show the relationship between a complex number and its conjugates quite successfully. Just a small number did not show that sine negative n theta is negative sine n theta. Just be careful that the student required to show, because it's a proving question. Advice to the teacher here is to make sure students can show the result by writing complex number in modulus argument form and understanding the exponential form. For part 2, there's quite a variety of ways of doing it, but the first one is the student actually using ei theta plus e to the negative I theta to the 4 and using binomial expansions. After the binomial expansion, students should collect the term e to the I4 theta plus e to the negative I4 theta together as a group. The other grouping is e to the I2 theta plus e to the negative I2 theta. So then they can use the results from part 1 to substitute into it. The other thing they need to do is on the left-hand side, they realize that e to the I theta plus e to the negative I theta is 2 cos theta. To the raised to the power of 4, so the left-hand side is 16 cos to the 4. Then they're equating the left-hand side to the right-hand side, and then they establish the result. Another way to do it is, again, they expand the left-hand side. And what they could do with the right-hand side, this is not a bad way to look at it. Instead of raised to the power of 4, they call it square square. So by squaring it first, they're only dealing with e to the 2I theta plus e to the negative 2I theta. Then they just replace that by 2 cos 2 theta. And then they square it, and then they use a double angle for cos, and they achieve the results. So it's very similar to the previous methods. So for this particular part, the majority of students were able to use binomial expansion, and they also use the result from part 1 to show that it's the desired relationship. So there's no problem with this particular question. The problem is a number of students did not use binomial expansion and index laws to simplify the expression properly. They just wrote it without realizing what to do with the index laws or misuse index law. And also they should relate to part 1. That would be useful or makes it easy for the question to prove the identity. The simple errors we found is actually 2 to the power of 4 equals 8 rather than 16. So for the advice here, students got to know the indices, and indices actually a major problem with many students. And don't forget that to use part 1. So the hence part using part 1 is really useful, and this part here then equating the real parts is another option for the student if they use binomial expansion. For part 3, they got the word hence there, so students should be using that. So hence integrate from 0 to pi on 2 cos to the 4 theta d theta. Okay, so this one here, they should just go and integrate this. So replacing from part 1, you can see that integrating this, replacing the expression from part 1, so the results is 3 pi on 16. If they don't use the hens, they use otherwise, that would have taken a lot longer because they have to break up cos to the 4 to cos square, and as you can see, they end up with the same expression anyway towards the end, but as it's involved many, many more steps in between. Well, the majority of students were successful in using D part 2 and integrate the trig functions and substitute the limits correctly. Well, the errors occur when students differentiated instead of integrated, or incorrect evaluation when they substitute into the integrand. Teacher makes sure that students use a reference sheet just in case they mixed up the differentiation integrations, so to make sure that they don't make mistake with questions like this. And also use the previous part to link to the question. Well, question 13, mechanics is the first part. So mechanics is 3 marks. We got vectors is 3, proofs is 3, and complex numbers is 6. So the total of question 13 is out of 15. So as you can see, that the topics and the outcomes for this question. I want to take more time now with 16 because that's a more involved type of questions. So this is beginning of question 16. So 16 part A, we have 2 masses, 2 mkg and 4 mkg. So they're attached by a light string, as you can see. Now, part 1, show that dv dt equals gm minus kv all over 3m. So for this particular part, there's 2 ways of doing it. The first one is to result the force as in 1 as a total. So the left-hand side should be 4 mg minus kv minus 2 mg minus kv equals the right-hand side is 4 ma plus 2 ma because it's balancing the force. And then they should get 2 mg minus 2 kv equals 6 ma. Therefore, A is mg minus kv over 3m. The other way is actually resultant force separately. So the left-hand side, the force on the left mass is 2ma equals T minus 2 mg minus kv, and then make the tension the subject. And do the same thing to the right-hand side on the forces on the right mass. 4ma equals 4 mg minus T minus kv, and substitute the tension from the left-hand side into that and achieve the result. Okay, so this part here, the number of students were able to handle the resolution of forces when more than one object or mass is involved. And they actually managed to write the net force on the system in one expression. and also understand the overall mass as being 6m. The common problems actually students seem to struggle because of the two different masses are not the same. And also, they were not aware that the tension is also a force. So it makes no reference to tension when they actually resolve the force. So teacher makes sure that the student can do the question using the linking force, in this case tension, to solve problems involving more than one object. Also, when they calculate the overall mass of the system, it should be 6m and not the average in the masses. I guess the reason for averaging the masses is because the 3m is in the answer. They just thought that they had to average it. Okay, for part 2, given that V is less than gm on k, show that the time is 3m on k ln 2. So from part 1, all they need to do here is to rearrange it, and finding t, integrate respect to v, the limit is from 0 to v. In this case here, as you can see, because we put the limits from 0 to v, there's no need to find a constant. And then they substitute t equals to 3m on k ln 2 to show v. Another method is actually, without putting the limits in, student integrate respect to v. In this case, they have to find the constant c. When t is 0, v is 0. So c is 3m on k ln gm. And then they finally have to substitute t as 3m on k ln 2 into it and show that v is gm on over 2k. The next one is probably one of the better methods, is actually use the definite integral. So the limits for v as well as the limit for t. As you can see, they substitute both sides into the limits into both sides here. So we derive at the end of it is v equals gm on 2k without any further substitution. So for this particular part, use the definite integrals and separation of variables. Actually, that's probably the best method because that's actually require minimum amount of working. The other thing is obtain an expression t in terms of v or v in terms of t, then substitute t into it. Execute successfully the appropriate integration techniques and could simplify the expression using the log laws. Is also some of the students did it that way. Well, the problem is some students did not integrate correctly with respect to t, or left out the constant c, or other errors occur in algebraic manipulations. So the advice is students actually need to make sure they know the general integration techniques. Also use the log laws correctly. And don't forget, it's an indefinite integral. Don't forget to add c and find c. For part B, part 1, the students have to prove that In equals 2n over 2n plus 1 times In minus 1. So method 1 is the student need to recognize that in this case here, the split is sine 2 theta or sine to the 1 2 theta and sine to the 2n 2 theta. So the split is 1 and 2n. And in this case here, what they need to do is to make sure that they integrated the sine 2 theta and differentiate sine to the 2n 2 theta. And then apply integration by parts. And they successfully show that. This is, I guess, it's also another way to do it. But actually, the first method is better. this one is they're splitting into sine square 2 theta and sine to the 2n minus 1 2 theta. This method, they require to change sine square to 1 minus cos square. And then they expand out the brackets. As you can see, the first part is actually in minus 1. But then with the cos square, they also need to split that cos square to cos cos so that they can use one of the cos as a derivative of sine 2 theta. So in this case, they need to differentiate cos 2 theta and integrate sine to the 2n minus 1 2 theta cos 2 theta. And they need to be a bit more careful with integration by parts. Also, they need to rearrange it and then achieve the required result. A number of students were able to explain the logic behind their proof, and it may not be immediately obvious, but what they've done moving from one line to another line in their proof and clearly indicate the values for u prime, v, and v prime. The common problems with this is a number of students did not split the original expression correctly. So that's leading to the incorrect integration by parts. Well, other errors is actually u prime from u and v from v prime. So the differentiation integrations were the problem. So teachers need to work with students on how they present the solution. So the setting out of solution using integration by parts, especially proving, encourage them to show u prime, v, and v prime, and makes it easier for the markers as well. And also the correct choice for u and v prime. Also, the other thing is crossing out and rewriting incorrect solutions, right? Rather than trying to change a numeral or symbol by overriding on the incorrect. So it's better to cross out and redo it, because by just changing the numeral and the symbol on top of it, it's difficult to read and understand what they're trying to write. It's really messy. Also, writing the given integral as sine to the 2n, 2 theta and sine 2 theta, or the other split. Don't forget that when you're differentiating sine to the 2n 2 theta, is to make sure they're using the chain rule to differentiate it correctly. For part 2, deduce in. The key word is deduce. So this is not a proving question. So what they need to do is to use from part 1. And they need to start showing that the first part is 2n over 2n plus 1 times in minus 1. So then they actually expand the in minus 1 to in minus 2. They got to do it until the last term is I naught. So we want to see how the pattern actually showing here. And students are required to find what I naught is. So they really need to just integrate sine 2 theta from 0 to pi on 2, and I naught happens to be 1. Because without the I naught, it's infinitely if they don't put it in. Some students actually just leave out the last term. Okay, so this one here is the same thing in terms of the split. So they split it and then they group it together, all the squares. But in this case, they left it with I1 instead of I naught. Finding I1 is far more difficult. As you can see, I1, to find it, they have to integrate sine cube, which takes a lot longer. But if they just stop at I1, they are required to find what I1 is, and I1 is 2 on 3. And they have to substitute into that, and they can derive what I and n is. This is another way of looking at it, is, again, very similar to the previous one. They're just expanding it, and they just substitute. I think it's the same as the previous page, really. So a number of students were actually we're able to find I naught correctly and also show clearly the final step to get the denominator as 2n plus 1 factorial. Well, the common problems here is when they're showing this, we need to see a few lines with actually steps showing clearly. And also we like to see the second last term and the last term so they're not fudging in another way, another word for that. Okay, there were shortcuts used by some students need to be careful consideration when showing the last steps. So try not to skip too many steps with the showing here, is to make sure that the markers can see clearly the working. So the advisor to teachers, students need to work on understanding that deduction and induction are two different types of proof. Also, don't forget to explain clearly each step. And they must calculate I naughts, or for some would be I1. Part 3. So what I have to show here is the Jn, which is n factorial all square over 2n plus 1 factorial. And this is to say that use the results from part 2 or otherwise. All right, so let's just go through. The first one, student got to realize that the substitution here for x is sine square. Differentiating sine square, and then substitute into Jn. So what they end up with now is sine to the 2n plus 1 theta cos to the 2n plus 1 theta. They then realize that have the same power to n plus 1. So they bring it inside the bracket is 2 sine theta cos theta to the 2n plus 1. Leaving the in front of that should be 1 over 2 to the 2n's. So that's need to be clearly shown for us the working out here. And then they use a double angle for sine 2 theta to replace. And as you can see, then they link back to In, which is from the previous part. And they derive the results. The other substitution is also going to work is cos square. It's not much different. They just have to be careful with the negative. So that's the same idea, but just be careful with the negative. Okay, this one here, what they did was they can start with the In from the previous part, then divide it by 2 to the 2n plus 2 to the 2n, and end up with sine to the 2n plus 1 2 theta. And then what they end up doing is they use a double angle to expand for sine 2 theta and backtrack it. And what they end up doing is to show that the results is Jn. And as you can see, then just go back to that last part. Then they show the required results by doing it that way, which is Jn. Okay, this is also another consideration, is they're starting with sine square, put the limits into it, and then they go x to the n times 1 minus x to the n, and put in the integrations. So as you can see, this by doing all the substitution earlier and then just put it in, that's also a good method for this particular question. Another method is this one here too. So start with In again, divided by 2 to the 2n, again with the split, and that is similar to the previous method that I've shown you. Okay, this one is starting with Jn, and as you can see, x equals sine square 2 theta. This time is much harder because it's sine square 2 theta, not sine square theta. And as you can see, with the correct substitution and then simplifying the trig expression, they end up with sine 4 theta. So with the sine square 2 theta, there's a lot more work involved, but they still get to the end results if they're careful with it. This is another method, which is, I think is a very clever method using integration by parts. As you can see, the student use integration by parts, but they got to keep showing until they can produce a pattern. And this is a really clever way of doing it. So the student realizing that, again, similar to part 2, the last term is they have to integrate 0 to the 1, or from 0 to 1, x to the 2 and x to the 0. And they integrate that, and they can show it as well. So this is a very clever way to do this part by using integration by parts. For this particular part, the student was successful when they noticed a connection between this question and the previous parts of the question. And also they recognize the need for the right substitution. So in the question would be a sine square or cos square would be the right substitution. Well, other methods that actually were shown, the number of students that actually apply it that way, and they're quite successful as well. What's the problem with this question is some student, actually a small number, decided it has to do with binomial theorem. So what they end up doing is just expanding it out. And also that makes it really, really difficult to do anything about it. So interesting expansion, but unfortunately lead to nowhere. So they got nowhere by using binomial expansion for this question. So this one here, what teacher needs to do with the students is to make sure that they actually recognize a trig substitution, a suitable trig substitution. And also try not to have too many multiple incorrect attempts, because that would just waste a lot of time. Part 4 is prove that 2 to the 2n n factorial all square less than or equals to 2n plus 1 factorial. This question just say prove that, didn't say what methods or how to prove it. Okay, this method is by far probably the best one, because they started by looking at quadratic expression is x times 1 minus x. And the symmetry of that is x equals a half, then the maximum value is a quarter. So we can then say that x times 1 minus x is less than or equals to a quarter. So therefore we can integrate from 0 to 1 raised to the power of n. So that's what Jn is, so we end up with less than or equals to 1 over 2 to the 2n. And then we substitute Jn from the previous line, the previous part, and hence we derive the results. So that's very elegant proving this one. The other method is actually some student did this, and it's quite logical as well. So we're looking at 2n plus 1 is greater than or equals to 2n, 2n minus 1 greater than or equals to 2n minus 2, and so on. And then we multiply the left-hand side and the right-hand side separately. And as you can see, we can show that inserting the term in between that's missing on the left and the right, which is the terms missing, is 2n, 2n minus 2, 2n minus 4, and so on. So then we derive in the left-hand side, there'll be 2n plus 1 factorial greater than or equals to, and on the right-hand side, we have two lots of the 2 to the n, so, and then n factorial and its square. So this one here is using the pattern. Another way for this one is also looking at from part 3. We can see that we replace it, so we got the integral of sine to the 2n plus 1 2 theta. But students have got to recognize that the limit is from 0 to pi on 2. And 2 to the 2n plus 1 2 theta is less than or equals to sine 2 theta. Now they really need to justify by using graphs, because as n increases, the graph of sine to the 2n plus 1 is actually smaller than the graph of sine 2 theta. And therefore, what they need to say is they then have to introduce sine 2 theta, replacing the sine 2 to 2n plus 1 into the integration, and have to integrate it. And they also substitute and rearrange it, and they end up with the proof here. For this one here, very similar to the previous part, again, they got to make sure that they're using in here. So got to explain to say that y sine to the 2n plus 1 2 theta is less than or equals to sine 2 theta. They need to have some sort of justification. Using graphs, perhaps the best option there. And then they integrate sine 2 theta. Some of them just say that sine 2 theta they integrated before, which is I naught, that's 1, and that's fine. Well, this also can be done by induction because all it says is prove. So if the student do by induction, it wasn't that difficult. So you can see that for step 1, just substitute n equals naught into that. And assuming n equals k is true, as you can see, if we start with the left-hand side and build up the induction, the algebra is not difficult to show that it's true. But unfortunately, only not too many students had to go at induction because the question was proving without telling them that they can use induction. This other method is actually understanding, again, the quadratic. So x minus a half all squared greater equals 0. Again, it's similar to the first method is a quarter squared equals to x times 1 minus x. And start with a quarter to the n and integrate it from there and rearrange it. And they're successful this way as well. Another one is some students actually rearrange it and make it less than 1, as you can see. So 2n over 2n plus 1 less than 1, because from B part 2. So then, as you can see that in is less than or equals to in minus 1. And we got I naught to be 1 from part B. And therefore, we substitute what in is. We make that less than or equals to 1, rearrange it. And also we achieve the results here, which is really good. I think this is also not a bad option here. There's another induction also is what students need to do is to realize that they're proving, in this case here, is less than or equals to 1. That should be less than or equals to 1 here. And again, if they recognize induction, I think they would be quite successful in proving that. Okay, this is another method here. What student did was to treat the function as x to the n, 1 minus x to the n, differentiate it, find the stationary point, and also they found that x equals a half is a local maximum. And they should have a graph drawn here with some justification so that you can see clearly Jn is actually less than or equals to 1 over 2 to the n times 1. And if they got that far, then they can just substitute, rearrange it, and they got to the result. Okay, this is because it's the last part of question 16. Well, it's difficult for many students. That's because they run out of time or they had too many multiple attempts in the previous part. But one thing that students actually were able to do is they need to explain why in less than or equals to 1 and not just simply state it. Prove each important step. So they'll be able to, they show the important steps, which is important. And they will clearly explain that the product of fractions and is 1 less than 1. Or that the powers of numbers between 0 and 1 get smaller. That's in terms of justification of the graph, especially sine to the 2n 2 theta is less than or equals to sine 2 theta between 0 and pi on 2. Also, they can use the diagrams of work to explain each step. And also they need to make sure they state at I naught, which in this case, they can state I naught from B part 2. Or they can actually find I naught if they haven't got B part 2 for I naught. The problem is a lot of students just simply say that In less than 1. That's not sufficient in this case here. Another common mistake was actually the student said the maximum values of the function, right? So in terms of sine 2 theta, they decided to say that, or x times 1 minus x sine 2 theta. So they actually do not have any graph to justify, and they just conclude that the area therefore less than 1 must be equals to 1 or less than. So I think it's hard to just saying it. So for this particular question, it's good if the student actually draw the graph and explain clearly. So this part here, like I just mentioned, that it'd be good if you have using the graph to solve the inequalities. And also considering the values of the integrals, not just the functions. The reason for that is because the limit is from 0 to pi on 2. If the limit is from 0 to 1, then we can just consider the y values of it, which basically the width is 1. But because 0 to pi on 2, the width of the rectangle is pi on 2, so the student can't just say the y value is the area. Well, that concludes question 16, and that consists of mechanics, 5 marks, vectors is 11, and that's the total of 16. Okay, I just want to quickly go through the multiple choice. I mean, you all got the RAP analysis, and unfortunately, I can't talk about the stats here, but like I said, that we've done that every year in terms of going through from the most common to the least common. So the most common results here is B, that's the length of this vector, which is 19. The next one is D, 361. C is 25. And the least common one is A, is 5. And the correct answer is B. So the majority got that right. Question 2, they asked to find the values of P and Q, dealing with the complex roots. Okay, so the most common response is B. The next one is D, and then A, and the least common response is C. And the correct answer is B. So the answer to this is P equals -6, Q is 10. Question 3, they asked to find the Cartesian equation of this vector. The most common response is C, then it's A, it's D, and it's B. And the correct result is C. Question 4, complex numbers. Which of the following diagrams best shows the position of Z squared over the modulus of Z? The most common response is A, then it's C, then it's B, and the least one is D. And the correct answer is A. Question 5 is simple harmonic motion, given acceleration and maximum velocity of 4. What's the period? The most common response is D. The next one is B, then it's C, and the least common response is A. And the correct answer is D. Question 6 is integration. So they just have to complete the square. The most common response is A. The next one is C, then B, and the least one is D. And again, the answer is A, which the most common response. Number 7, if 2 to the n minus 1 is not prime, then n is not prime. That's the statement. So that's a proposition. And then it says that which statement disproves the proposition. The most common response is D, then B, then C, then the least one is A, and the correct answer is D. That's because 2 to the power of 11 and 11 is a prime number. Question 8. If n is even, then if n is a multiple of 3, then n is a multiple of 6. Now, this is about the negations of the statement. So the most common response is D, then it's B, then it's C, and the least one is A. But this one is the correct answer is B. So that's not the most common response. It's the second most common response. So the answer is B. N is even and n is multiple of 3, but not a multiple of 6. Question 9. What's the maximum values between 0 and 2 pi? So the most common response is C. The next one is B, and then D, and the least one is A. The correct response is C. And for this one here, student could do it by just recognizing its maximum at pi on 2. They substitute into it and they find the modulus. It should end up with 2 root 5. Or they could change e to the I theta to cos theta plus I sine theta and simplify the expression, and they will realize that the maximum value is 2 root 5. This is number 10. The most common response is B, and then A, and then C, and the least one is D. And the correct response is B. Okay, so that concludes the multiple choice section. Okay, thank you. All right, I'll just put up on the screen here. I don't know which. Okay, so as you can see, in terms of the multiple choice, they're just the breakdowns of the topics. Right, we got vectors, complex numbers, vectors, complex, mechanics, calculus, proof, complex. So here's overall breakdown for the papers. So we're looking at 18% on proof, 15 on vectors, 21 on complex, 16 on calculus, and 30 on mechanics. So that's a breakdown for the 2020 HSC Extension 2. And that's the end of the recording.